Have you ever found yourself looking at some really complex system, maybe, I don't know, setting up a smart home, or even just seeing footage of an automated factory floor and just wishing, man, I wish someone could just break this down for me. Just give me the shortcut to understanding how it all connects. I think we've all felt that need for clarity when things get complicated. Well, today should be interesting. We're doing a deep dive into something called Eclipse 4diac. It's an open source setup, basically designed for distributed industrial systems. Think measurement, control, that sort of thing. And what's really key here is that it's built on a specific standard, IEC 61499. So our mission today is really to unpack what Eclipse 4diac is all about. Why is it such a big deal in industrial automation and also in research? We'll look at how it works, why it matters. Think of this as your quick guide to getting up to speed on this important tech. Okay, so let's start right there at the foundation. You mentioned it's built on IEC 61499. Now, for maybe those of us not living and breathing industrial controls daily, what exactly is IEC 61499 and why is it so central for these distributed systems?
Well, that's a great place to start. What's fascinating here, I think, is that IEC 61499 isn't just, another spec sheet. It's really a different way of thinking. Historically, a lot of industrial control was very centralized, sequential. Imagine like a single orchestra conductor dictating every single note, right?
Okay. Yeah.
But IEC 61499, it moves towards a more modern, event-driven, and crucially distributed model. So think more like a jazz ensemble, maybe, where each section knows the tune, knows its cues, and can react independently but still works together.
Oh, I like that comparison. More flexible.
Exactly. The standard is designed for distributed systems. So instead of one big central brain, you have lots of smart devices, sensors, controllers, actuators, all networked. Each one capable of some local intelligence, local control. This is, well, it's just vital for making complex industrial processes reliable, scalable. And 4diac, its goal is explicitly to provide a stable base for this kind of next-gen system, supporting both research and industry adoption.
That orchestra versus jazz ensemble analogy really clicks. It makes sense why distributed is so important. And you mentioned 4diac helps kind of manage all this. It has four main parts, right?
That's right. It's a whole ecosystem.
You've got the 4diac IDE. That's the development environment.
The IDE.
Yeah.
Then there's 4diac 4TE, which is the runtime, the thing that actually runs your application on the hardware.
Okay.
There's also 4diac lib, a library full of pre-built function blocks.
Ah, the building blocks.
Exactly. And finally, 4diac SYS, which provides example projects to help people get started.
So IDE, Forte, Lib, and SYS. Got it.
Put them together, and yeah, it's pretty comprehensive. The IDE is where you design everything. Forte makes it run. Lib gives you those reusable components. You call them building blocks. I like the smart Lego bricks idea, too.
Ah, yeah.
And SYS gives you those practical examples to learn from. It really is an end-to-end kind of setup.
Okay, so those smart Lego bricks. That brings us to the main design studio, right? The 4diac IDE. You said it's an IEC 61499 compliant environment. And being open source, does it build on other platforms? Like I think the source mentioned it's based on the Eclipse platform. Does that help with integrating other tools?
It absolutely does, yes. It's built on the Eclipse platform, which is, well, it's huge in the software world. That foundation makes it much easier to integrate other plugins, which adds a lot of flexibility. But the really core thing about the IDE, and this comes straight from that IEC 61499 philosophy, is its application-centric design approach.
Application-centric. What does that mean in practice?
It means you think about the application first, the overall logic, the behavior of your entire system. You design that before you even worry too much about the specific hardware you'll run it on.
So wait, you design the overall orchestration like we talked about before you even pick the specific instruments? That sounds backwards, but also kind of brilliant. Less getting bogged down in hardware details early on.
Precisely. You start by building the application for the whole system. You take those function blocks, those Lego bricks from the library, the ones you create, and you connect them together into what's called a function block network, or FBN. You define the interactions, the logic, the flow of data and events. Then, once you know what hardware you'll actually be using, which PLCs, which sensors, etc., you add those devices to your project configuration in the IDE. And then the IDE helps you map or distribute parts of your application onto those specific devices. So you design the application logic before you decide which physical device runs which part. It makes prototyping and adapting to different hardware setups much, much easier.
That top-down approach makes a lot of sense for these really spread out systems. So what specific tools does the IDE actually give you to, handle all this? From that initial design right through to running it and checking if it works.
All right, well, it's a pretty complete toolkit. First, you've got the System Explorer. That's kind of your main project view, where you manage everything, your applications, your system configuration, your hardware setup, even a library of function block types specific to your project.
Okay.
Then there's the application editor. That's the visual canvas, where you actually build those function block networks, dragging blocks from the library, connecting inputs and outputs.
The Lego building part.
Exactly.
Yeah.
Then you've got a hardware editor specifically for defining your physical setup, specifying the devices, setting their parameters according to the IEC 61499 model.
Makes sense.
And importantly, there are type editors. These let you create your own function blocks if the standard library doesn't have exactly what you need. You can make basic function blocks with low-level code, composite ones by nesting other blocks, service interface blocks for communication, even special adapters.
So you can extend it quite a bit.
Oh, yeah. Then, once your app is designed and hardware defined, there's the distribution editor. This is where you actually map the function blocks or even whole networks onto the specific resources, the controllers you defined earlier.
The where part.
Right. And after mapping comes deployment. The IDE lets you selectively download the application parts to the right devices.
And then hoping it works. Or is there debugging?
Oh, definitely debugging. There are robust monitoring and debugging features. You can watch the values of data points in real time. You can force values to test responses, trigger events manually.
That's crucial.
Absolutely. And there are even testing functionality specifically for checking individual function blocks. You can set inputs manually, use breakpoints to pause execution, step through the logic line by line if needed. It really gives you the tools to see what's going on under the hood.
Wow, okay. That sounds like a really comprehensive environment, especially for an open source project. And it's clearly not static, right? The sources mentioned it's grown with new versions, improvements, new features, even performance boosts in the runtime. But how does a project like this keep evolving? What's the sort of support system behind it? It's not just code, is it?
No, not at all. And if we connect this to the bigger picture, that growth is really tied directly to its community. It's quite active. 4diac makes a real effort to participate in events to, as they put it, get in contact with its users and share results and future plans. It fosters collaboration.
Ah, so feedback loops.
Exactly. It's a living project. For instance, they run things like winter schools. I think there's the first 4 days of Eclipse 4diac Winter School planned for 2025. They hold virtual community meetings regularly. And looking back, they've had events like 4 days of 4diac in 2019, Eclipse Insight workshops, and a whole series of dedicated 4diac users workshops at the ETFA conference, going way back to 2010.
Wow, that's over a decade of consistent user workshops.
Yet that level of sustained engagement really shows. It means the project evolves based on what people are actually doing with it, what challenges they face, and where the research is heading.
That history really speaks volumes about its stability and relevance. So, okay, if someone listening is thinking, all right, I want to check this out, maybe get their hands dirty, what kind of resources are out there? Is it easy to get started?
Oh, definitely. There's a lot of documentation available specifically geared towards getting started. You can find resources to help you learn about the IEC 61499 standard itself, which is important context. There are guides to understand the whole Eclipse 4diac framework, the components we talked about.
Right.
There are step-by-step tutorials for installing everything, for walking through the IDE examples. They even have a frequently asked questions section, which is usually helpful.
Good old FAQs.
Yep. And beyond the basics, there's more detailed info, too. Things like how to configure I/O for different hardware platforms, specifics on the communication protocols it supports, even documentation if you want to get involved in developing 4T or the IDE itself.
So materials for users and potential contributors.
Exactly.
Right.
Now, because it's open source, there are clear ways to get support forums, mailing lists probably, and of course, information on how you can contribute back to the project if you develop something useful or find a bug. They try to make it approachable.
Okay, so wrapping this up then, what does this all really mean for you, our listener? Well, it seems Eclipse 4diac is a pretty powerful package. It's open, it's built on an important industry standard, and it's designed specifically for these complex, distributed industrial automation tasks. You get this comprehensive IDE that focuses on designing the application behavior first, which sounds incredibly useful, and then helps you deploy and debug it. Plus, there's strong community behind it, constantly evolving it. It's not just software, it's an ecosystem.
Yeah, and thinking about that evolution, it really raises an interesting question for you to maybe ponder. How might the continued growth and adoption of these open application-centric systems like Eclipse 4diac actually reshape the whole landscape of industrial control? Could it make these incredibly complex systems not just more efficient, but maybe more accessible, more adaptable for the next wave of engineers and researchers coming through. It's something to think about